This tutorial is about types of reactions, synthesis and decomposition. They kind of go together. So whenever you have a reaction where two or more things combine to form only one compound, that is synthesis. So some examples are if you have A plus B, and they combine to form one compound AB, that is the format of a synthesis reaction. So here we have aluminum and oxygen separated, but when they are combined into one compound, aluminum oxide, that is a synthesis reaction. And here's another one over here. Barium oxide plus water. On the reactant side, they're separated. And then on the product side, it is one compound, barium hydroxide. That is what synthesis looks like. Decomposition is the opposite. That is when you have one single compound and it is breaking up into its elements or smaller compounds. So opposite of synthesis. The general formula is one compound AB splits apart into its pieces A plus B. So here we have water splitting apart into its pieces, hydrogen and oxygen gas. Here is sulfurous acid splitting apart into its pieces, water and sulfur dioxide. Here we have two examples, which I'm going to go through, two reactions, and we are going to determine if they are synthesis or decomposition. Then we're going to write them out and balance them. So what I'm going to look for is my clues. Remember, synthesis is the format A plus B gives you compound together AB. So that's what I'm looking for synthesis. For decomposition, it is AB already put together, coming apart into its pieces. That's decomposition. So if we read the problem, silver carbonate, so that's our first compound, decomposes into silver oxide and carbon dioxide. We are going from one compound to multiple pieces. Does that look more like synthesis or decomposition? Well, since we only have one compound before our arrow, before our reaction, it is definitely decomposition. Plus, look at it says decomposes. So that is decomposition. The next one is solid magnesium is burned in excess oxygen to produce magnesium oxide. Well, yes, we see the word burn, so it is a combustion reaction, but we're going to focus on the part that it is synthesis as well. How do I know it's synthesis? Because I am starting with two smaller pieces, and what I am ending up with is only one final compound, so it's being put together. That is synthesis. So yes, this is synthesis, and yes, it's also combustion because of the burning part. Now that we know what type of reaction it is, we need to write it out and balance it. So silver carbonate is an ionic compound, so we need to take a look at the charges. Ag is +1, carbonate is 2-. So it becomes Ag2CO3. Decomposes into silver oxide, also an ionic compound, so check the charges. Silver +1, oxide 2-, so it becomes Ag2O, plus carbon dioxide, which is a covalent compound. We just write 1 carbon and 2 oxygens. So that is our reaction. It's decomposition. We need to make sure that it is balanced. So what we do is we check the atoms on each side. On the reactant side, there are 2 silvers. On the product side, there's 2 silvers. Good there. Reactant side, 1 carbon. Product side, 1 carbon, also good. Reactant side, 3 oxygens. Product side, 1 here, 2, 3 there. So this is already balanced. So let's move on. Solid magnesium. Magnesium is burned in excess oxygen. Remember, your diatomics. Have no fear of ice-cold beverages. So oxygen is O2. That yields magnesium oxide. Ionic compound because it's a metal and a nonmetal, so you need to check the charges. Magnesium oxide. Well, Mg is +2, O is 2 minus, so it becomes MgO. Last thing we got to do is make sure that it is balanced. So we have O2 here on the reactant side, so we need to put a 2 in front of the MgO. Then to go back and balance the magnesium, put a 2 there. And there you go.